Okay, so let's start from the top, no word problems. Just do a combination problem. 7 factorial over 7 minus 4 factorial, and then you take that and factorial. Obviously, you'll have more space in the test to simplify this problem, but I'm going to rewrite this as 7, 6, 5, which cancels out the 4, and then on the bottom 3, 2. You need to show me that you didn't use a calculator, even if you did. I get 35. This is the same thing, 7 factorial over 7 minus 4 factorial, which is 7, 6, 5, 4. So 5 times 4 is 20. 20 times 42 is 840. Okay. This one's a little bit different. What you're going to need to do is figure out the value of 7 factorial, put it here. Then figure out the value of 4 factorial, 4 times 3, 12, 24. That one's easier. And then 7 minus 4 factorial is 3 factorial, and 3 times 2 is 6. So I'm just going to pick up my calculator. I don't have the fancy one, but if you want to use the fancy one, you can. Okay, and I get 50, 40. I actually suggest using the fancy one, but since I've already started, make that look a little bit nicer. Now I'm going to subtract 24. 50, 16, divided by 6. Oops. I get 836. Okay. All right, let's get into some word problems. All right, 3 different. So we've got entrees, desserts, beverages, fundamental counting principle. 3 times 7 times 4. 21 times 4 is 84 choices. Okay. Let's see how many different ways. We're talking about just the gymnastics team, but there's a gold, a silver, and a bronze, so the order matters. And it looks like there's 3 options. So 8 factorial over 8 minus 3 factorial, which is 8, 7, 6. 8 times 7 times 6, 336. 336 weighs. Okay. All right, this time we have highlighters, and I only need 5 out of 20. So it doesn't matter if I pick this highlighter or this highlighter. So that looks like combinations. 20C5, 20 factorial, 20 minus 5 factorial over 5 factorial. This is just going to be a workout because it's a big number. So 20, 19, 18, 17, 16. And as soon as I get to 20 minus 5, boom, that hits the 15. And then the bottom 5, 4, 3, 2. 5 times 4 gets rid of the 20. 3 times 2 is 6, and with the 18 is the 3. Now I'm going to use my calculator. And I get 1, it's a big number. There's a lot of choices. Let's say options, I don't know. Okay. All right, talking about M&Ms. So this is just basic, looks like experimental probability. So they want to know the green. So how many greens are there? 6 out of how many? 6 plus 9 is 15, 17, 21. Make sure you simplify 3/7. Okay. If you're going to use this calculator, you can go 6 divided by 21, and then go second PRB. Second PRB, and it simplifies it for you. Oops, well, it makes me see I made a silly mistake, so there you go. Careful about going fast when it's your last test. All right, you don't choose red. So if you don't choose red, you choose green, brown, or yellow, and that makes 19 over 21, and you can't simplify it. You choose red or yellow. So reds, there are 2, and yellows, there are 4. That makes 6 over 21, which I know correctly simplifies to 2/7. Okay. 2-digit number is randomly selected where 0 through 9 are possible. That means you have a total of 10 options. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The first number is odd. I like to list them so I can see it. Second number is greater than 5, 6, 7, 8, 9. So I have 5 options out of 10, and I have 4 options out of 10, and then I can just multiply, which is 20 over 100, which is 1/5, or I could have simplified, cross off the 2's, and there's still 1/5. So they want to know for this one, what's the probability of hitting the shaded region? So I've got to find the area of the square, which is 8 times 8, which is 64. I've got to find the area of the circle, which is pi r squared, which is pi times. Well, if this whole thing is 8, that means half of it is 4. So that's 16 pi. Okay, so we know that to find probability, it's the total, which is the square, over the part we're talking about. Well, the part we're talking about is 16 pi is the circle. So I can just simplify that as pi over 4. And if it lends itself to do that, I prefer you doing that than to give it to me as a decimal. Now, what if this time I said, I want the probability of not hitting the circle, but hitting inside the square? So if it said something like that, it would still be the same total, it would be the square, but this time you would have to go square minus circle. So let me say it again. If I this time asked for the probability of hitting this pink area, to get the pink, it's square minus circle would give you the pink. So then in that case, I would go 64 minus 16 pi over 64, which lends itself dividing by 16, 4 minus pi over 4. And then you could either leave it as 4 minus pi over 4. I'm okay with that. Or if you want to, you can go 4 minus pi divided by 4, and then give it to me as a percent. So that'd be 21%. And honestly, I'll be okay with you doing it in the other one too. Why don't you just give me both? How's that? Okay, so that's what I'm going to ask for on this one. Give it to me like this and with a percent. Okay? All right, another experimental probability, the probability of choosing a diamond. There aren't actually 26 diamonds in the deck, but this is an experiment. So 26 over, to get the total, I add them up, and I get 97. If I'm not sure if it can be simplified, I go like this, and then I second PRB, and it's still 26 over 97, so I can't simplify it. Probability of not clubs and not spades, which means it is hearts or diamonds, and 13 plus 26 is 39 over 97. 39 divided by 90, second PRB, it's still the same thing. Done. Okay, find the probability of tossing a coin 4 times. 1, 2, 3, 4, and getting heads every single time. Well, I have 2 options, 2 options, 2 options, 2 options. So that means I know that there'll be a total of 16. Now, I understand normally when I do this, you want to say 1/2, 1/2. But if this was heads, then this would be a 0, because you have to get you can't get a tail, okay? And then you can't get it, so it's almost too complex. So it's just easier to list it. So in other words, what I would do is I would go, okay, the only way is heads, heads, heads. Hold on, let me pause it. So if it's all heads, there's no other way to do that, because if I go tails, heads, 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 they're not all heads. So there's only one chance out of 16 to get it. Okay, rolling 3 number cubes. The first one's odd. So when you look at a number cube, let me remind you what a number cube is. A number cube is a dice. Okay, that's why they call it a cube, because it's technically a die. So I have an option of 1, 3, and 5. So that gives me 3 options out of a total of 6 sides. The second is a 2. So there's only 1 2 on the cube. Don't take the number 2 as part of the probability. Like, where is it? There is only 1 2. And then the third number is less than 4. 1, 2, 3. That's 3 out of 6. Okay? So I can multiply across if I want. And then I can simplify, or I would just simplify right away, and I get 1 over 24. But I want to show you, if I wasn't sure, I could go 9 divided by 216, and then go second PRB, and it gives me 1 over 24, which is what I got.